Hello, today I'm making a video about Git and GitHub. So this video is probably mostly going to be useful for you if you maybe have already a passing familiarity with it. Maybe you've used it a little bit once or twice, but maybe you don't feel like you fully understand how it works or what exactly is the difference between Git and GitHub. And so I'm going to today go over some of these things, like first of all, what is it and why do we use it? And then a little bit about how we download code from other people's projects on GitHub, how we would use it to host our own code, and then lastly, how we use it collaboratively, working with other developers on the same project. So that basically would be covering Git cloning, pushing, pulling, merging, resolving conflicts, that genre of things, which probably covers like 95% of what I do when I'm using Git and GitHub. It's not going to be extremely comprehensive and go into like all the things that you can do with it. But if you already have kind of used it maybe, but you are still a little confused, hopefully this will be helpful for that. Okay, so starting with like what is it and why do we use it? Okay, so it's confusing because like the words Git and GitHub, our Git is included inside GitHub, so the relationship between these things is sort of confusing and unclear. But it's important to think about the difference between things that are local on your computer and then things that are like in the cloud on the internet. And sort of a simplified way you can think about the difference between Git and GitHub is that Git is the version control software that is on your computer. And GitHub is like a website that allows you to host code in the cloud. So Git is software that you have to install on your computer, and we use it for version control for code. And so what is version control? Version control is, when you are writing code and then you save it and then you make updates to it and things change and you're adding things, you want to always be able to be saving the code at specific points so that you can later like refer back to it and find things that you did in the past, or if you've made a horrible mistake and have to revert to something that you did before. Git is the version control software that can allow you to basically save previous copies of your code. Then that happens on your own computer. So GitHub, again, is a website, basically, and it allows you to, after using Git, like push your code into the cloud so that other people can see it and access it, and also that, it's a way that you can collaborate with other developers on the same project. And so, bringing them together, we use Git to track the code changes on our own computers, and then we use GitHub to save those changes on the internet. And then when you're working with other developers on the same project, the GitHub in the cloud is sort of the place that allows you to bring your different code together. So now that we know what it is, why do we use these things? So as I mentioned before, it's really useful to keep track of your old code, and be able to have a place where you can go and look based on the date or based on like other stuff, to see what you did in the past on a project. The other thing, one reason we use GitHub, an important reason, is that it allows us to collaborate with multiple developers on the same project. As you can imagine, things can get pretty complicated when you have a copy of your working project code on your computer and then your collaborator has a copy on their computer, and then you're both making changes at the same time. That stuff can get really messy, and GitHub is a way that it sort of allows you to make it not messy and have you end up making one project together. GitHub is also really useful just to share your projects online. When you make something and you want to release the code, or you're making something for class and you want to share the code. For that reason, you can put it on GitHub easily. And that's like a place where people go to look at the code that other people wrote. And there's also, relatedly, there's sort of a whole universe of open source development. So people making projects, there are a lot of software projects that are like very large software projects that are open source, which means that like anybody can contribute to the projects. For from all around the world, and there's a sort of a process for contributing code to projects and having the people who maintain the project sort of like incorporate the code you wrote into their projects. Like we can use GitHub to do all those things. So, so let's get started and, first do one of the most basic things that we do with GitHub, which is downloading code from like other people's repositories. So a repository is like a folder for your code, essentially. And on GitHub, you upload these repositories or like these folders of code or other things, files, essentially. So if, on GitHub, I find a really cool project that I want to download the code for, I guess the simplest but probably worst way to do it is I can look at all these folders and I see one here, and then I can like copy and paste it into my own folder. But that's probably not a good idea. What you want to do is actually clone the repo so that you have a project or you have the folder on your own computer, and then you can make changes or play around with it or do whatever you want. So I already have, my GitHub account here. I also have Git already installed on my computer, so I'm going to assume that you have those things. So when you go to somebody's repo, public repo, and you hit this big green code button, there's a few options for how to download the code. I would recommend, I'm not going to cover it here, but I would recommend setting up SSH if you're going to be doing this more than once, because SSH allows you to clone a repo onto your computer without having to enter your GitHub username and password every time, which can get pretty annoying. You can just like Google how to set up SSH on GitHub essentially and link it to your own machine so that you can just copy this URL. So if you didn't do that, you would use HTTPS, which would require you to on your command line, log into GitHub every time, which is annoying. But because I have SSH set up, I can just copy this. And then I'm going to go to my command line. And so say, I'm on my desktop, I want to clone this repo into my desktop folder. And so the command for that is git clone, and then I copy the URL. And it looks weird on my command line just because like bash does this thing, which is very annoying when you copy and paste. But anyway, so I've done that. I did git clone, and so now I've created this folder called pet_cursor.js. So I can just like go into that folder, and I can see all the code that is in this repo is now on my personal computer. I can do whatever I want with it. Before I go any further, I want to say that even though in this video I'm going to be using command line for Git, you don't actually have to use command line for Git if you don't have to. It's not like inherently cooler or better to use the command line. There are other tools that you can use, like there are GUIs you can use. So GUI stands for GUI, or graphical user interface, basically like apps that you can use. So I think GitHub has like their own, they have their own app called GitHub Desktop. And, actually there's one that I use called SourceTree, which is also good, also free. And, for me, so I use the command line for Git most of the time when I'm doing JavaScript, web stuff, Python, that kind of stuff. But I actually prefer to use SourceTree when I'm doing Unity because, for Unity projects, there's like big assets and things like that. And things can get pretty messy in the command line very quickly. And so basically there's nothing wrong with using a GUI for Git if you want to. If you want to use command line, that's fine, but you don't have to. So don't feel pressured to do that if you don't want to. All right, that aside, I'm going to do command line right now just to show you how to do it. But the commands are actually the same on the GUIs and command line. It's the same process, basically. So we've gone over how to pull somebody else's project onto your local computer. Another thing you probably want to do with GitHub is create your own repos and upload your own code onto GitHub. And so this is how you do that. So I'm going to go to my desktop. I'm gonna make make a folder for a cool project called cool project. Okay, so now in that folder, cool project, let's make a file. So you can use the touch command to make a file. I'm going to make a file called script.js. And because I use Visual Studio Code and I've also installed their like command line tool, I can type code and then dot. So dot usually means like this current folder. And it'll actually nicely open up a VS Code window for this folder. And so, you know, I see here, so I'm in cool project. Let me make this a little bigger. Cool project, my script, my very cool script called script.js. And then, you know, my script is going to be like that. So this is my very good code. And now I want to upload it to GitHub so everyone else can see it. And so this is how you do it. You can do these things in slightly different order, but this is like how I like to do it. So I'm in the folder I want to upload into a repo, cool project. So the first thing I want to do is initialize Git. So having Git installed on my computer already, I can use it in my terminal. So I type git init, and it says it initializes an empty Git repository in this folder. And so one command that you might want to use all the time, or I do at least, is git status, which sort of tells you like what the status is of Git inside this current project. And so it says on branch master, no commits yet. Untracked files, my one file, script.js. So the first thing I'm going to do is I'm going to track the file by adding it. So we do git add, and I could do git add script.js, but I like to do git add period, because that means git add everything in this folder. So now if I do git status again, you'll see that there's a new file that's like, you know, now being tracked by Git called script.js, no commits yet. So the next thing I have to do is commit it. So I do git commit and then -m, and then I have to write a commit message, which can be my first commit. Wait, no, you can't do exclamation part. It like messes it up. All right, first commit, that's my commit message. Okay, git status again. All right, we see on branch master, nothing to commit, nothing, working tree clean. That's because I've committed everything that I have. All right, so at this point I can go to GitHub, and I'm going to, I guess I can do it here. Yeah, so I can make a new repository, and I'm gonna call it cool project. It doesn't have to be the same name. You name it whatever you want, but this is what's gonna be like public. And well, I'm actually gonna make this a private repo, but you can make it public if you actually want other people to see it. And you can add these things, but for now, I'm just gonna create repository, an empty one. So you see like Git sort of has some suggestions for how you add projects into your repo. So to be clear, right now there's two separate things that have happened. I have a folder on my own computer called cool project with a script. And then I've made an empty repository on GitHub called cool project, and they're not linked right now. So what I want to do is link these two things up and then upload my code into cool project in GitHub. So because I've already initialized it inside on my computer, I have to, the way that we link it up is that we have to add origin, add the remote origin. So I'm going to do that. So I'm going to copy this line. So I'm say git add origin, and then like where that origin is. Okay, so I added it, and again, this is like weird, looks weird just because of the way, again, Bash works. But you can check if the origin has been linked up by doing git remote -v. And now you can see that it is indeed linked to my GitHub project. But now I need to push it. Well, there's actually one more thing I need to do before that. So you can see here that GitHub has this sort of recommended command, which is git branch -m main. So this is actually kind of a new thing. So one thing you'll notice that like in my repository, because this is default for Git, it says when I make a Git repo locally, the default main branch is called master. And so one thing that has changed pretty recently is that GitHub now encourages you to change the name of your default branch from master to main. And this has been a thing that people have been talking about for a while, and it seems like it's finally happening this year. People feel like the word master is not really like an appropriate word to use for this kind of stuff. So basically, we these days we like to use the word main. That's the reason why you might see, most repos, especially older ones, use master, and then maybe some newer repos are starting to be called main in terms of the default branch. We'll get a little bit more into branches later. So I'm going to do this. Actually, I'm going to do this command git branch -m main, and I think the -m means sort of like a rename and move the default, which is, so right now if my previous git status says on branch master, and then this one after this command, if I do git status, it's now on branch main. So now that is done, I can just I can push my code. So I already committed it. I've already added the file that I want tracked. I already wrote a commit message, so all I have to do is git push -u origin main. I keep forgetting what the -u does, and I usually don't use it, but it's fine. So I do that, and then it says it's writing, and then great. So now if I refresh this, you'll see that my code is up on GitHub. My very good code is here. So that's, so I've uploaded my code, but if I'm assuming I'm working by myself on this project, I make changes to it, I add files, and I want to update my repo. So the way I do that, basically, say I add a new file, maybe let's add a README. So one thing that's useful on GitHub is that if you make a file called README, I think it has to be like capitalized this way, readme.md. A .md file is a markdown file, which is usually used for documentation. So in my README file, and it's using the markdown syntax, which you can look up. But if I'm like, hello, this is my project, and then you can use markdown. Like, I think this makes something a title, like Nicole's cool project. All right, so I'm adding this README file. I just saved it. So now if I do git status, it will find that there is an untracked file. So I'm going to do git add git commit, and it's good practice to write useful, for your own sake, to write useful commit messages. So whenever you make a change and you want to commit, you should describe what you did. And then I can do git push origin main. Okay, so now if I refresh, we will see that our README has been added with this cool markdown. And this is my project. So this is useful, say you're making a folder or repo for a particular class or something like that, and each week you add to it. So you would just do this. You would just make sure to add the files, write a commit message, and then push it. Okay, so here's where things get complicated, which is if you are working collaboratively with other developers. So basically, things get complicated because you have to, if you're both changing the same files and working on stuff together, things can get pretty messy if your code doesn't match, basically. And so GitHub, there's best practices for how to do this, but I'm going to show you generally how this works. So say I have a collaborator on this project. This is going to be kind of weird because it's just going to be myself doing it. But it's still important to remember that, I have my local computer here, my collaborator has their local computer here, then GitHub is like the internet in the middle, and then we use that to sort of both push our code and pull the code from other people or from the other collaborator and like merge the code together. So I can actually just edit this file here, which I wouldn't recommend doing normally, but just to pretend that there is another person working on this project and they have made a change to this. So maybe they added something. So they're like, we're going to add a variable called cat name, and the cat name is Disco. So imagine this is not me, but this is like Nicole 2 on a different computer made this change. And you can see actually it's the same stuff where you have to write a commit message. I think their default just says update script, which is fine for here. So I'm going to say commit changes. And so now this file in GitHub looks like this. It has this variable cat name, but my version on my local computer doesn't have that. So the way that I would like receive that update to the code that someone else made, that Nicole 2 made, is that I have to pull it. So basically, but if I do git status, you'll find that it still says I'm up to date, and that's because git in my command line is only looking at my local computer. So it doesn't know that in GitHub, the project has already been updated. But if I know that it's been updated, I'm going to pull. So I'm going to do git pull origin main. And ta-da, I pulled the code, it updated it. Now I have the code that's here on my local computer, which is great. And then, however, the reason I could just pull that is because there were no conflicts in my code. Usually when somebody else has added something or added a file or something like that, it's your Git will automatically can just like add that to your files because there's no conflicting stuff in the folder. However, say Nicole 2 has like made another change. Cat name is now potato. Meanwhile, on my end, I'm like, the cat name is onions. And, I'm working on my code here. I'm like, the cat name is onions. I do the thing. I add the file. I write a commit message, or I'm like, cat name is onions. And I push. So I get an error. So it's going to tell me, fail to push. Updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same. Okay, yeah, so basically like the other person has made a change already to the repo. I didn't know about it. I'm trying to push, but I can't because there's I have to pull first before I have to pull the changes before I can, I have to pull the most recent version of the project before I can push my changes. So I'm going to try to do that. So I do git pull origin main. And then this stuff happens. So you'll notice that in my code, we suddenly have this like weird stuff that appeared. So we have this like these like arrows, and it says head, and then there's like this, what do you call this thing? Like a separator line, and then I have these other arrows in this long string. So the reason the colors are here is just because I have the GitHub like extension on my Visual Studio Code. If I didn't have that, it would be the same stuff, but it just wouldn't be like color highlighted nicely for me. But I do recommend that for your text editor, you install the GitHub extension because it's just like easier to see. Okay, so what's happening here? Now I have two things here. It says cat name is onions, cat name is potato. And so this is a conflict because the variable cannot be two things at once, right? It has to only be one of these things. On the GitHub, the cat name is potato, and then my local version, the cat name, is onion. So I have to resolve this conflict before I can before I can push my own code up there. And it's hard to see because it's like very light here, but another nice thing that my text editor has with the extension is I can just click these buttons that says accept current change, which I think just means like my version, original version, which was onions, would get picked, or accept incoming change. I don't know how accept both changes works. I don't think it works. It would break your code, but you could try it. And so, or, I could click that button, which is just nice, or I could do something like, say, I'm like, no, actually it is onions. All I have to do is just like, delete the stuff that isn't onions, and this resolves the code, and I can save it. You can see I'm just going to undo it so that like, if I click accept current change, it'll do the same thing. It just deletes all that extra stuff. And so I'm like, okay, that's good now. And by the way, the reason why this is squiggly is because ESLint, I think, just says like it's just like I'm not using this variable, but you can ignore that. So I've resolved this. So now I can let's try this. Solve conflict. Okay, yeah, so I think basically that worked. So now if I refresh it, it should be onions because I've resolved it on my end. So this will be a pretty common thing that you would run into if you're working with other people. I mean, usually you would try to avoid getting to the point where having conflicts because you have like a coordinated working system, or people are working on different branches, which I'll show you real quick, like what that means. But this is like the general process for working collaboratively with somebody. You write a bunch of code, you push it, they pull your changes, they're also writing code. And that's how it works. And then the GitHub sort of hosts the canonical code that you have pushed. And you can see we go to, it's like a list of commits somewhere. How do I see all the commits that I have? I forget where it is. But you can see basically all the changes that I've made so far. So I can talk a little bit about pull requests. This is probably not something you will get into for your own projects, or even if you're working, honestly, with a small team. I mean, it depends. So pull requests are a more organized way to merge code from different contributors together. If it's just you and another person, you could use it, but you don't have to. But a lot of times, so if you're looking at open source projects where it's sort of a large software projects, people are not just merging random people's code straight into the project. They want to make sure that it works. They want to review the code first. And so pull requests are used for that purpose. And so the way that often we will do pull requests is by using branches. And you can use branches not just for pull requests, but it's very useful if, say, you want to work on a particular thing. You're like, I'm making a new feature. I don't want to disrupt the main code while I'm like messing around with my experimental feature. And when it's ready, we will merge it together. That's like a good reason to use branches, for example. So to make a branch, you have to make it locally, and then you have to push it to GitHub for it to be like in the cloud. So I do git checkout. To make a new branch, you have to do -b and say I'm going to do like my branch called new feature. So now I'm on a branch called new feature. If I do git status, it should say that I'm on the branch new feature. I'm not on main anymore. So say I want to like add a new feature to my code. Let's add like a dog name equals Stephanie. So now I've added my new feature. And so let's commit it. So like, well, first, we have to add it, git add dot, git commit add dog name. And we can push it. So git push origin, I have to make I'm not going to push it to my main branch. I want to push it to a new branch on GitHub called new feature. And you'll see that both locally, so I'm on new branch locally, if I check out my main code, git checkout, so to switch branches, you do git checkout, and then if it's an existing one, you just type the name without the -b. So git checkout main, you can see that it doesn't have the dog name because that's not in this branch. But if I do git checkout new feature, it does exist in this one. And then if we refresh our repo here, we can see that there are 2 branches now. There's one called new feature, and this one has the dog. Okay. So, we have 2 branches, and say, the main branch, which is your main branch, like the default branch, say like we have this new feature that's very exciting. I want to merge it. I want to add the new feature from that branch into the main branch. So the way that I would do that, and the way that I would do that is first you have to check out, you have to be on the main branch, and then all you have to do is say git merge new feature. And this should work because there are no conflicts here. So I just merged it, great, and then I can push this change. You always have to push for it to be on GitHub. Git push origin main. Now if I go to the main branch, it also has the dog name, so because I've merged it. That's cool. So most of the time if you're just like merging simply like that, you can just do git merge, assuming there are no conflicts. If there are conflicts, you'll have to fix them as usual. But say we want to make a pull request instead. So let's go back to our new feature branch. And let's change the dog name again to, I don't know, Benjamin. So I've made a change here, and instead of doing, actually I have to add it. I have to commit it. I've pushed it. So now you'll see there will be a difference, and our main is still Stephanie. Our new feature is now Benjamin. So if you're doing pull requests, basically the way that this would work is as the person who maintains the repo, this is confusing because I'm both the person maintaining the repo and then I'm the person doing a pull request. But say I want to submit a pull request for my new feature branch. So I would do new pull request. And then I think I'm going to click this one. Yeah, and I'm going to create pull request, change dog name, and I can write a comment of like why I'm leaving this pull request. And I just I think the dog's name should be Benjamin. And there's let's leave it at that. Okay, so I've submitted a pull request. Now, because I have access to this as the maintainer of this repo, I can see that there's this pull request, and luckily there's no conflicts here, but I can see how many commits there are. There's only one. I think I should be able to see, let's see, where's that? Okay, yeah, if I look at it here, we can see what the change would become. Stephanie would be removed and it would be replaced by Benjamin. Click review changes. I can leave comments about it. And if it all looks good to me, I'm going to merge it. And so now the pull request has been merged. And this is the same as doing that git merge, but it's just a more organized way if you really want to review the code, look at it on the interface, for example. This makes that, easier. And so that's sort of how pull requests, how branches work. And the last thing I want to show you, just, this is not that important or anything, but just GitHub has like many, many features and things like that. One thing that I actually like is their issues feature, which is a useful way to keep track of, problems or like bugs or new feature ideas for your project. So you can write a new feature for yourself or for another project. Another thing you'll see is that for open source projects, if people are trying to use the code but they run into a bug or something like that, they will submit an issue. And so I can submit an issue that's like, the dog name is bad. And, I actually use issues a lot for my own projects just to remind myself of like something I want to fix later. So you can do it for yourself, basically, as sort of project management stuff. And I can even assign myself, there's no one else on this project, so I can assign myself. You can do, you can apply these features like, I don't know, you can say it's a bug. Oh, it's not a bug. Call it enhancement. Yeah, so I can submit the issue. I can write a comment, whatever. So I say the dog name is bad. So I'm like, okay, I have this issue, and say as the developer, I decide to fix this issue. First of all, let me make sure I'm back. I'm just going to go back to the main branch. It doesn't matter that much. But actually I have to pull. So now there have been changes that have been made in GitHub. Yeah, and so I want to pull the changes. It's always good practice to pull before you push if other people are working on the project. So say let's change the dog name again. The dog name should be like I don't know why I'm like drawing a blank on dog names. Tofu. Okay, the dog's name is Tofu. Here's a cool trick. Remember that GitHub issue? It has a number. The number is 2. So first I'm going to add. And then in my commit message, I can say changing dog name. And then I can do number 2. Oh, sorry. It's really hard to read that on my terminal. No, that doesn't help. Here. Okay. Let's just say number 2 dog name, just so that you could read that more clearly on my weird terminal thing. Okay, and then I do git push origin main. So what's cool is that, when I refresh, we'll see that, it was pushed up there, but when I go back to the issue, it automatically links up the commit that I just pushed because I referenced it in the commit name by saying number 2. Which is very useful. And another cool trick is that, say, let's make it, we'll change it again. And this time, if I say fix number 2, and I refresh this issue, it actually closes the issue, which means the issue is fixed. Like, so if you type fix and then reference the issue, or if you type close the issue, I think like a few things like there's a few, I think fix or close will do it. It'll actually close the issue for you automatically, which is just a nice little thing. There's like a lot of other things on GitHub, but this covers almost all of what I do on GitHub. Again, mostly if you're just thinking about hosting your own code on there for your own projects, for a class or for something else, you do it we went over that. And then the more complicated stuff, which is working with other people, like this sort of goes over how it works. Sometimes you might run into other more complicated issues, but you just Google that and then try to get out of it, essentially. But those are sort of the basics of it. I hope that is useful in some way to you. Okay, Thank you. Bye-bye.